So a quick recap as to what we've done in the past two sections when we looked at proving triangles congruent. We've looked at four different methods that work. So I'm going to put proving triangles congruent at the top. And the methods that we looked at, the first one was side, side, side. The second one was side, angle, side. We've also looked at angle, side, angle, and angle, angle, side. We know these work. Hopefully you've been thinking though, are there other methods that we haven't talked about that also work? And those would include angle, 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 and side, side, angle. Do these work? I'm just going to put work question mark. We're going to try and show this. Right? And the way that we're going to do this is through GeoGebra. So the first one that we're going to start with is angle, angle, angle. Meaning if I have three angles in one triangle, congruent to three angles in another triangle, will those triangles be congruent? Remember, congruence is the shape has both the same size and shape. Okay, so here's our first one, angle, angle, angle. These triangles, they look to be about the same size. They definitely are the same shape because they're both triangles. But if I were to move this triangle, notice what happens. They both have the same shape, but this triangle off to the right does not have the same size. It's quite a bit bigger than the original triangle. They all have the same angle measure, but it's completely different size. So angle, angle, angle does not work. It does not produce congruent triangles. The other one is side, side angle, meaning I have two sides and an angle that's outside of them. So showing this relationship, here's my side, side angle relationship. I have 6 and 11, both congruent to 6 and 11, and then this 30-degree angle down here in the bottom. This 30-degree angle is fixed, meaning that as long as this point lands on this side over here, on this dashed line, that's a triangle. Okay, so that's what I'm going to do. I'm going to move this side length. Notice how I can just move this side length freely because this angle down here is not fixed. So if I move this up, there's a triangle, and it looks to be congruent as the one on the left. However, since this angle down here, P, is not fixed, I can continue to rotate this side length. Notice what happens again. I formed another triangle. The problem is that this triangle is not the same shape as this one over here. Meaning side-side angle could produce congruent triangles, but it won't always produce congruent triangles. So that means that side-side angle does not work. Okay, so really the four ways that we have so far are these right here. There are some relationships that work specifically for right triangles, so we're going to show you those as well. The first one that they state is leg-leg. You don't necessarily need to know this one. There is one that you really will need to know, but leg-leg isn't as important because if we look at the relationship over here, it looks like side angle side. So leg-leg really is the side angle side relationship. The next one that your book states is hypotenuse angle, meaning the hypotenuse of one triangle is congruent to another along with another angle. So when I look at this one looks like angle, angle, side relationship. Again, that was one of our relationships that we came up with in sections 4 and 5. Another one, leg angle. Well, this one represents angle, side, angle, so it's really no different than what we've already discussed. The last one is important, And notice what they call this one, hypotenuse leg. You're going to want to put that with your list. And it represents triangle congruent in right triangles, specifically. Okay, so we now have 5 ways of proving triangles congruent. Hypotenuse leg is specifically for right triangles. And the reason that I want to point this one out is because it resembles one of these already from our list. So looking at this one, hypotenuse leg, so I have the hypotenuse, which is located across from the right angle, and a leg, any leg, either one of them, on the triangle, congruent to the hypotenuse and leg of another triangle. When I look at this scenario, it's representing side-side angle. And if you remember, just a little bit ago, we said side-side angle doesn't always work. But the ironic part is that in a right triangle, it does work. But instead of calling it side-side angle, they're trying to represent it a different way. So we're going to call it hypotenuse leg. Okay, so if you have a right triangle, please note that you can prove that they are congruent just by using hypotenuse leg. And that would be the last one for proving triangles congruent. So you now have 5 ways to prove triangles congruent, which are side, 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 angle, angle, and angle, angle, side. And then specifically for right triangles, you have hypotenuse leg.